Hello everyone, welcome to Module 8 of the Database Management Systems class. In this module, we will discuss database management approaches. Upon successful completion of this module, you will be able to explain the characteristics, advantages, and disadvantages of distributed database management systems, describe client-server systems, describe the ways databases are accessed on the web, identify XML and related document specification standards, define data warehouses and explain their structure and access, explain the general concepts of object-oriented database management systems. There are several database management approaches, such as the centralized approach, the distributed approach. The centralized approach to processing data is one in which users access a central computer through personal computers and workstations, and this has dominated organizations from the late 1960s through the mid-80s. The introduction of comparatively cheap computers during the 80s facilitated the creation of computer networks. Networks connected these computers so users could access data located on their local computers, including data located anywhere along the entire network. In this module, we will examine the issues involved in distributed databases where a database is stored on more than one computer. Organizations often offload or shift data communication functions from central computers to smaller computers to improve processing speed. Similarly, organizations often use client-server systems to offload database access functions from central computers to other computers. Client-server systems will also be discussed. Additionally, we will discuss about accessing databases on the web and the importance of XML or extensible markup language and related document standard specifications. Data warehouses and object-oriented systems will also be covered. Distributed databases. In the distributed database management approach, computers at various sites are connected with communications networks or network. A distributed database is a single logical database physically divided among networked computers. Distributed database management system is a DBMS capable of supporting and manipulating distributed databases. Computers in a network communicate through messages. That is, one computer sends a message to another. Access delay or a fixed amount of time is required for every message. Communication time equals access delay plus the delay volume per transmission rate. Characteristics of distributed systems. A distributed database management system is either homogeneous or heterogeneous. A homogeneous distributed database management system is one that has the same local database management system at each site. A heterogeneous distributed database management system is one that has at least two sites at which the local database management systems are different. Heterogeneous distributed database management systems are more complex than homogeneous DDBMS. All distributed database management systems share important characteristics. These characteristics include location transparency, replication transparency, and fragmentation transparency. Location transparency. Users can access a distributed database from a local site or from a remote site. Location transparency is a characteristic of the distributed database management system that users do not need to be aware of the location of data in a distributed database, regardless of whether they are accessing the database from a local site or a remote site. A local site is the site where the user is found. A remote site is the site other than one where the user is found. Replication transparency. Replication allows users at different sites to use and update copies of a database. However, data replication creates update problems that can lead to data inconsistencies. The distributed database management system should correctly handle the updating of replicated data. Replication transparency is a characteristic of the distributed database management system that users are unaware of the steps taken by the distributed database management system to update various copies of data. Fragmentation transparency. A distributed database management system supports data fragmentation if the distributed database management system can divide and manage a logical object among various locations under its control. The main purpose of data fragmentation is to place data at the location where it is most often accessed. Fragmentation transparency is when users are unaware of fragmentation. Advantages of distributed databases. When compared with a single centralized database, the distributed databases offer the following advantages: local control of data, increased database capability, system availability, and improved performance. Disadvantages of distributed databases. Distributed databases have the following disadvantages: update of replicated data, more complex query processing, more complex treatment of concurrent update, local deadlock, which occurs at a single site in a distributed database, global deadlock, which involves more than one site, more complex measures, two-phase commit, in which one side acts as the coordinator, more difficult management of data dictionary, more complex database design, and more complicated security and backup requirements. Rules for distributed databases. C.J. Dade formulated 12 rules that distributed databases should follow. The 12 rules are: local site independence, central site independence, continuous operation, location transparency, fragmentation transparency, replication transparency, distributed query processing, distributed transaction fragment, hardware independence, operating system independence, network independence, and database management system independence. Client-server systems. In the client-server system, there are two types of architectures: the file-server architecture and the client-server architecture. In the file-server architecture, the file server stores user files on the network. In the client-server architecture, the server is a computer providing data to the client. A server is also called a back-end processor or a back-end machine. Clients are computers connected to a network and used by users to access data. Clients are also called front-end processor or front-end machine. There are two types of architecture within the client-server architecture: the two-tier architecture and the three-tier architecture. In a two-tier architecture, the server performs database functions and the client performs presentation functions. When the client performs the business functions, each of the clients is known as a fat client. When the client performs only the presentation functions, each of the clients is known as a thin client. In a three-tier architecture, clients perform presentation functions and the database server performs the database functions. Separate computers called application servers perform business functions and interface between clients and the database server. Advantages of client-server systems. Compared to the file server systems, a client-server system has the following advantages: lower network traffic, improved processing distribution, thinner clients, great processing transparency, increased network, hardware and software transparency, improved security, decreased cost, and increased scalability. Web access to databases. Important concepts to note about the web are: the Internet, which is the worldwide collection of millions of interconnected computers and computer networks that share resources, is an essential portal for all organizations. The World Wide Web, or simply the web, is a vast collection of digital documents available on the Internet. A web page is a digital document on the web. A web server stores web pages. A web client is a computer requesting a web page. Each web page has a uniform resource locator or website address. Hypertext Transfer Protocol, HTTP, is the data communication method used by web clients and web servers to exchange data on the Internet. A web browser is an application software or a computer program that retrieves a web page from a web client. Transmission Control Protocol, Internet Protocol, TCP/IP, is a standard protocol for communication on the Internet. Web pages are usually created using the Hypertext Markup Language, or HTML. Static versus dynamic web pages. Web pages that display the same content for all web clients are known as static web pages. Dynamic web pages are pages whose content changes in response to inputs and choices from web clients. Server-side extensions or server-side scripts are instructions to tell the web server how to process the page. Client-side extensions or client-side scripts are other instructions for web browsers to process on the client. A three-tier web-based architecture is made up of web clients, web server, and a database server. XML. HTML is a text-based markup language. It contains pieces of code or tag that describe the content and appearance of web pages. However, HTML does not describe the structure and meaning of the data it contains. Web pages created with HTML only pages created with HTML only are not interactive. Another language is needed to add interactivity to web pages, especially those designed for commerce and those involving financial transactions. Extensible Markup Language, or XML, is a meta-language or a language used to define another language. XML can be used to define new tags that can define the meaning and structure of data. XML can be used to add interactivity to web pages. An XML document should begin with an XML declaration. Extensible Hypertext Markup Language is a markup language based on XML. It is a stricter version of HTML. A document type definition, DTD, defines the elements, the attributes, and the element relationships for an XML document. An XML schema is a newer form of DTD that more closely matches database features and terminology. Document type definition and XML schema define the structure, characteristics, and relationships of data. The presentation aspects of an XML or an XHTML document can be described by style sheets. The Extensible Style Sheet Language, XSL, is a standard language for creating style sheets for XML documents. Data warehouses. Online Transaction Processing, OLTP system, is a class of software programs or database software designed to support web-based transaction-related applications or transaction-oriented applications. Users use transactions when interacting with a relational database management system. A data warehouse is a subject-oriented, integrated, time-variant, non-volatile collection of data in support of management's decision-making process. Data warehouse structure and access. A conceptual shape of a data warehouse is known as a store schema. A conceptual shape of a data warehouse is known as a store schema. Within a data warehouse, a fact table is a table which consists of rows that contain consolidated and summarized data. A fact table also contains a multi-part primary key. A dimension table is a table which contains a single part primary key that serves as an index for the fact table. Access to a data warehouse is accomplished through the use of online analytical processing, or OLAP software. A data cube is a shape for visualizing a data warehouse as a multi-dimensional database. Data mining consists of uncovering new knowledge, patterns, trends, and rules from the data stored in a data warehouse. Rules for OLAP systems. E.F. Codd and his colleagues formulated 12 rules that OLAP systems should follow. The rules for online analytical processing include multi-dimensional conceptual view, transparency, accessibility, consistent reporting performance, client-server architecture, generic dimensionality, dynamic sparse matrix handling, multi-user support, unrestricted cross-dimensional operations, intuitive data manipulation, flexible reporting, and unlimited dimensions and aggregation levels. Object-oriented systems. In addition to storing data consisting of numbers and text, some organizations store complex objects such as graphics, drawings, photographs, video, sound, voicemail, spreadsheets in their relational database management systems. Relational database management systems store complex objects using special data types, generally called binary large objects. Object-oriented database management systems are used with applications whose functions is on complex object-oriented database management systems are used with applications whose focus is on complex objects. What is an object-oriented database management system? The foundation for relational database management systems is the relational model. Object-oriented database management system, or OODBMS, is a database management system in which the data and the actions that operate on the data are encapsulated into objects. An object is a set of related attributes along with associated actions. Objects and classes. An object is an instance of a class. In object-oriented database management systems, each entity is represented as an object rather than as a relation. Objects can contain other objects. An object can contain a portion of another object. Methods and messages. Methods are the actions defined for a class. Methods are defined during the data definition process. The steps in a method are executed when a user sends a message to the object. Inheritance. A key feature of object-oriented systems is inheritance. For any class, you can define a subclass. Every occurrence of the subclass is also considered an occurrence of the class. The subclass therefore inherits the structure and methods of the class. Additional attributes and methods can be defined for the subclass. Unified Modeling Language, UML. The Unified Modeling Language is an approach used to model all aspects of software development for object-oriented systems. Unified Modeling Language includes a way to represent database designs and several types of diagrams, each with its own specific purpose. The class diagram is the most relevant diagram type for database design. In the Unified Modeling Language, rectangles represent classes. The lines joining classes represent relationships and are called associations. In a class diagram, the visibility symbol indicates whether other classes can view or update the value in the attribute. Multiplicity indicates the number of objects that can be related to an individual object at the other end of the relationship. When one class is a subclass of a second class, the second class is called a superclass of the first class. A generalization is the relationship between a superclass and a subclass. Rules for object-oriented database management systems. Rules for object-oriented database management systems serve as benchmarks to measure object-oriented systems. The rules are complex objects, object identity, encapsulation, information hiding, types of classes, inheritance, late binding, computational completeness, extensibility, persistence and performance, concurrent update support, recovery support, and query facility. For this week, you'll be required to read Chapter 9 of the textbook, that is pages 282 to 315, complete Quiz 8, complete Assignment 8, complete Test 4, submit your final project, take part in Discussion 8. Please take note of the due dates and plan accordingly.